You are given an array of prices where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So if you're already here watching this video, I'm assuming that you've already given this problem a shot. But if you haven't, try it, because we're about to get into an explanation of what this problem means, and some of those observations will actually help us in trying to understand this problem. So what does this question mean? It just means that we're going to have some low number and then some high number, such that the low number is always going to be on the left and the right number is always going to be on the right. And we're going to find the difference between those two numbers. And not just that, but we want to find some combination that will give us the greatest difference between those two numbers that we pick. So let's actually write that down. We want a low number that is to the left and a higher number to the right, and find the max difference between any numbers given these constraints. So with these observations, I hope it's starting to give you an idea of how we can approach this problem. And a brute force solution that won't work but will put us on the right track is to pick the first number and then just iterate through the rest of the array, saying, all right, does 7 and 1 work? No. Does 7 and 5 work? No. And just on and on. Then we go to 1 and then we go to 5. We say, does 1 and 5 work? Yes, it'll give us a 4. Does 1 and 3 work? Yes, it'll give us a 2. 1 and 6 work? Yes, that'll give us a 5. And we can log that answer. We can evaluate all possible combinations within this array, and we can just save the maximum difference between the two different values and return that answer. This would work, but it's inefficient enough that we would get a time limit exceed if we were to try to do this. So we need to think of a better approach. So again, the approach that we just mentioned was an O of n factorial. And now we need to think of some approach that will be a better runtime. And looking at our constraints, we'll probably need a linear time. So we need a O of n solution, which just means, can we look through this array once and get our answer? So let's think of a couple more examples, and maybe the answer will jump out at us. Let's say we had this array, and I think just looking at this, we can see that the 2 and the 9 is going to be our biggest difference. So let's try to modify this array a bit, and let's see if we can get a different answer. So let's see if we change this to a 1. It's no longer going to be 2 and 9 that are going to give us our greatest difference. It's going to be this 1 and this 9. So how about instead of doing every possible combination, we only focus on the smallest numbers that we come across. So we can start with 2, and then we start to iterate through the rest of them. But when we come to this 1, we can say, all right, you know what? 1 is less than 2. So instead of saying just 2, let's just iterate from 1 to the rest of the other numbers. And so long as we capture whatever differences that might exist to the left of our current minimum, we can consider what max difference can be in our right portion. So on a pass of this, it would be 2 as our minimum. Then we evaluate 7. We find the difference of 5. We go to the 1 now, and we say, oh, 1 is less than 2. So let's change our minimum to the 1. And let's continue with observing all the other elements. This would give us an O of n solution, so let's try this out. So let's start setting up our variables. Let's call it low and I. We're both going to set these equal to 0 and 0. These are just going to be the indexes that we're taking hold of. And with this, we're just going to say while true. This is just going to be an infinite loop. And we're going to make some condition to break out of this. So when our I value is greater than or equal to the length of prices, we're going to break out of this loop. Also going to need some other variables as well to maintain our current highest. So let's just say current lowest equals 0, current highest equals 0, and current highest profit equals 0. Actually, let's set this to the first value. And on every iteration, we want to move our pointer to the highest value to the right. So h plus equals 1. And on every iteration, we want to consider if the numbers that we're pointing to are going to give us a new highest profit. So we're going to say something like current highest profit equals max current highest profit, current highest minus current lowest. So let's update our highest value now. So when do we update our current highest? When we say if current highest is less than prices of highest number that we're pointing to. So as we iterate through, we're first at 2, then we get to 7, and we say that 7 is currently higher than 2. So we're just going to say current highest equals prices H, that new number that we're pointing to. So now let's update our lowest value. Current lowest when it is greater than prices. Now, what are we going to put here? On every iteration, we're moving our highest pointer to the next one. And we want to say that if the observed value is less than our current lowest, we want to change our current lowest to that observed value. So prices H, that observed value is going to be, once we have this condition, we want to say current lowest equals prices H. But there's something else that we need to do here now as well. Remember, we can only have our highest value be to the right of our current value. So if we set our current lowest value to 1, then we also need to set our current highest value also to this 1 as well, and then continue iterating from here. So current highest equals prices H as well. And also we need to update the pointer to our lowest. So L equals R. We can have this as H or L. It really doesn't matter. And again, just to make this crystal clear, remember, if our current highest was 7, but then our current lowest was 1, we need to make sure that the current highest needs to be equal to or greater in index value to that value. All right, let's just return the current highest value now, and let's see if this runs. All right, looks good. Actually, looking at this, it doesn't even look like we need 2 different pointers, but this is fine. It won't increase our O of N runtime. I'll leave a link to the code in the description below, and please like, subscribe, and let me know in the comments if you have any questions or what questions I should take on next.